In this section, we're going to talk about solving basic trig equations. So to solve these equations, you're going to use the rules of algebra that we've learned earlier this year. So some options that you can use are factoring, and then one that pertains more to what we've been doing this chapter is using the identities, which is basically substitution, which we had done before. So the directions for these problems are either going to specify one of these three things. So when they ask for the principal roots, you are going to restrict your answers to the inverse trig functions domain. So what you learned in section 5 about the inverse trig functions and where to look at them on a graph, that's going to be the range that you look for your answers in. If it asks you for solutions in the interval of 0 to 2 pi, that's radians, and obviously 0 to 360 is degree. Basically, you will look around the unit circle or one period of the graph. If it asks you to find all the real solutions, that means you can keep going on and on and on forever. So look beyond one period of your graph, or you could go around the unit circle multiple times. So essentially, all you're going to do is add the period of the graph to the answers that you get from one of the methods above. So if it's a sine, cosine, secant, or cosecant, you're going to add plus or minus, or just plus actually. You'll add plus 2k pi to all your answers. If it's tangent or cotangent, you'll do plus k pi. Again, if they would ask you to do this in degrees, it'd be plus 360k or plus 180k. So just a quick basic solving example here. If you have to find the principal root of 2 sine x minus 1 equals 0. First of all, that minus 1 is not in parentheses with the x, so it is free to move to the other side. And we're trying to get the x by itself, so we'll divide by the 2. And then at this point, you can solve this in several different ways. You can look on your circle. So again, principal root, we have to think about our inverse trig functions. So if you're looking on the unit circle, you can only look in quadrants 1 and 4. If you're looking on your graph, you can look at anything between negative pi over 2 and positive pi over 2. Or you could make a triangle. So with our x angle, sine is opposite over hypotenuse. So those sides correspond to your 30, 60, 90 triangle. And since x is across from the 1, that must be the 30-degree angle. So if it's in degrees, you could say 30 degrees, or you could say pi over 6 if they ask you to find it in radians.